Thank you for tuning in to This Automation Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week we discuss technologies used in automation. This week, Paul Oppenheim, automation specialist with Brenner-Fiedler, is here to discuss timing delays, timers, timing signals.
Timers and time delays, yes.
Okay. Thanks for joining us, Paul, and
Absolutely.
thanks for clarifying. So, timing delays. What kind of different timing delays are we talking about?
There are actually different types of timing delays, but even before we get into that, let's first kind of discuss why we even need one in the first place.
Okay.
And where they even are applicable.
I'm game.
Okay, fantastic. So normally when we work with timers, before that you probably are working with something, let's say like a sensor or some sort of a device where you're sending a signal.
Okay.
So let's say we are working with a sensor and we're looking at we're looking at shampoo bottles today, and we're going to place labels on those bottles.
Okay, they're coming by on a conveyor.
They're coming exactly.
Okay.
So
Okay.
we have a bottle coming by, and the sensor would see it. And let's say, for instance, for whatever reason, a label was supposed to be applied and it was not, and you needed to then, let's say, kick that bottle off the conveyor because it's missing. Exactly.
Okay.
Well, without any type of a time delay, you can think of it as soon as the sensor sees the bottle, the signal is being sent right there, denoting that no label is present. So
right, the sensor's fast, right? So
exactly.
No label and output on.
Right, so at that immediate point, it's already trying to send a signal to kick that bottle off.
Okay.
And once that bottle is past the sensor, now the signal is no longer being sent, and so the actuator, whatever, is probably now retracting back to its position after it's extended. And perhaps just based on where the equipment is actually set up, you can't actually have the actuator right there, right when the bottle is being seen. Maybe have to delay a little bit of time, we'll say, before you kick it off. Hence, we're going to get into timing delays.
Okay, got it. Okay,
so
now we know why. Why? Here's an example of why we might need a timing delay. What type of timing delay would we use in that scenario? And then what's all the types, or a lot of them at least?
Absolutely. Sometimes. Okay, so an example what you might want to use in that particular case is what was called a on delay.
Okay.
So in other words, although the sensor sees the leading edge of that bottle coming by, you want to delay the time it takes for that signal to actually turn on and then send the signal to the actuator to kick the bottle off the line.
Okay.
So let's say, for whatever reason, based on the speed of the conveyor, if it was a fairly slow conveyor, let's say, perhaps you want a 2-second time delay.
Okay.
Between the time where it actually sees the bottle and actually kicks the bottle off.
And you can always figure out, okay, my line speed is this many feet per minute.
Correct.
And that's feet per second. It's this many feet away between the reject station and the sensor. Boom, there's my time.
Exactly. Cool. Now, some sensors actually will have the timing features built into them. Some do not, in which case you would purchase a separate timer in which you take the output of that sensor and tie it to the timer.
Or maybe you use a timer in your PLC.
That is correct, exactly. Okay. So there's several options you can take.
Okay.
So that delay is considered an on delay. Okay. There are other ones as well. There's one also known as an off delay.
What a shock.
Exactly. Didn't see that one coming, huh? Okay, so there's an off delay as well. Okay. What that does is it extends the length of time of that signal itself.
Okay.
So for instance, as opposed to the on delay, where as soon as the sensor sees the target and it delays the time before the output turns on, here what happens is as soon as the sensor sees the target, the output turns on. But then let's say after the target has passed by the sensor, even though the sensor signal turns off, the off delay portion kicks in, which that signal is actually extended for an additional period of time.
It's a lingerer.
Exactly.
Yeah, okay.
So some examples of where you might want to use something like that. Maybe not necessarily, let's just kind of switch gears a little bit. Maybe we're not looking at a...
no more shampoo.
No more shampoo coming on. Maybe we're working with a liquid level sensor in a high heat application where there's boiling liquid coming up. Okay, and let's say with those bubbles or whatever, you have some sort of a probe or something that's saying when I reach a certain point, let a PLC or some device know I'm at a certain point, or even more importantly, maybe my liquid level is dropping, and I want to know when I get too low to say I need to add more chemical or whatever the case is.
Okay.
Well, the problem with, let's say, like a boiling liquid, if I have a sensor that's fairly sensitive, the actual bubbles themselves, as they're kind of rippling or whatever the case is, create a lot of what you call chatter.
Okay.
And when that happens, you get multiple signals being sent. Let's say when I'm starting to reach that one critical point, that threshold point, and now my PLC or computer or whatever it is might be confused because I have these. It's turning on and off. Let's say exactly.
Yeah. Okay.
So when you use an
Kill
off
your
delay,
pump or something.
exactly. When you use an off delay, it helps to smooth that out, so to speak.
Okay.
So if you know that the amount of time it takes. Generally, let's say either filling or draining a tank or something, let's say, again, if it was approximately 1 second of travel from when it crosses that sensor point, you might say, okay, I want to have an off delay of a little bit more than a second, maybe a second and a half, so as to ignore that chattering, that bubbling.
You want to overfill or something so that it goes above your trigger sensor by just enough so that it's not constantly filling. Activating a pump or something. Okay.
Exactly.
I see. Okay, I can think of some examples for that. Okay, cool. We got on delay, we got off delay.
Yep.
What's get weird? What else is there?
There's other delays as well. There's one known as a one-shot.
Okay, it's weird now. What is that?
It's getting kind of crazy. What a one-shot is whenever you get a signal, let's say, again, from a sensor or an input of something of that nature, the output will turn on for a specific period of time regardless of how long that input to the signal is. So let's say, for instance, if I had a one-shot set for exactly 1 second, let's say, and I send a signal from a sensor, and let's say a target is being seen by the sensor, and it takes a quarter of a second to come by. As soon as it trips the timer will have a one-shot of 1 second. So even though the target passed by, and it only took like maybe a quarter of a second to pass by, we lengthen that time to about a full second because perhaps what we're setting it to is the actuator or whatever the case might be might require a longer period of time for it to react.
Yeah, you know, I'm thinking of like an air cylinder. You're gonna have to turn the valve on for long enough to actually extend. Right, and maybe it's only a 1 second.
Exactly, just for it to be able to recognize it's being prompted by that signal or whatever the case is. And then also vice versa, if there's if the part is coming by, let's say it takes 10 seconds for it to cross, but you just need the actuator to actuate for just a brief period of time.
Yeah,
again,
tap something.
Exactly. So as soon as it saw that leading edge of that target coming by, the output again will only be specified for 1 second because that was my one shot.
Okay. You just mentioned leading edge. So could you do a one-shot based on the falling edge also? Is that possible?
There is. Sometimes you have to you start to get a little bit more into what we're calling logic. So we use what's calling, there's different types where we have, let's say like a rising edge or falling edge signal. And some sensors will have those built in. There's some timers that will have that as well. And
sometimes you have to step up to the controller of some
Right.
type.
Sometimes people will even kind of gang two timers together. Like they might even have a one-shot delay of time before the one shot, where literally as the part comes by, it sees it, but then it says, even though the part has passed by, delay for a certain period of time. And then send a one shot for 1 second as well, so you can get to even more and more.
It's like a combo meal.
Exactly.
Alrighty.
Yes.
Okay, what else do we've got? One shot, on delay, off delay. You can combine them.
That's right.
What about a flicker? I've heard about a flicker.
You've heard of
What is this?
A flicker timer. Basically, what that is if you want to be able to have an output be turning on and turning off and just flip-flop back and forth for a certain period of time.
It's
a
like
lot of those are used for,
pulse generator, kind of.
Basically, yes. We'd use it for, if you're using a timer with a relay type output, normally that's used for, let's say, like a light, like an emergency light, if there's been like an error. Sometimes simply just turning on the error light isn't enough to grab attention from a user to just come over. Somehow having that flashing light seems to grab attention better. And still use a flicker timer to control those lights.
Okay, so there's a flicker turns on and off. Can you adjust the time that it's on versus the time that it's off? Is that a type of flicker, or how do you do that?
When it comes to using a flicker timer, whatever happens to be your on time, that will be the off time as well. So example, if my flicker on time happened to be set for 2 seconds, the off time would also be 2 seconds. And then however you adjust the on time, the off time is equal to that.
Okay.
So if you want them to be different, so let's say you
Yes,
wanted your
I
on
do.
time, if you wanted your on time to be for, let's say, 5 seconds, and your
Yeah.
off time to be off for an hour, let's
Okay.
say,
Yep.
that's what's called a twin timer.
Twin timers.
Twin timers,
Okay.
exactly. So
Wow.
that takes you to an entire new type of timer delay.
Wow. Okay.
So
So now we've got on delay, off delay, one shot, a combo of those,
yes,
flicker, twin timer.
correct.
Are there any others? That
I'm
you
sure
know
there
of
probably
that-
are.
There's a weirder one out there than this.
There are different types of other
but
timers
we've got
out there.
we've got a big chunk of them. Here,
A good
right?
portion
We're
of
good?
those that I've mentioned are either individual timing components that you can purchase.
Okay.
Either
You buy a block and you throw it in your machine, and it's like this
exactly,
tiny-
you can buy the ones that they just plug in, almost
Yeah.
just like into
panel
like
mount
almost
thing,
like
yeah.
relay sockets that they just
Yeah.
plug into.
Okay.
Those are individual timers. You can get obviously a PLC. Obviously PC based logic, and then also even some sensors are intelligent enough to actually have some of that
built-in,
logic built in. Correct.
Cool. Okay. Awesome. Well, that's all the time we have for this week. Paul, thank you very much.
Yep, you're welcome.
Appreciate you making the walk down the
Yeah,
hall
it was-
to the
It was
Laura's recording
it was a good
studio.
time.
Yeah.
Yes.
Free
Okay.
puns.
Very good.
Free puns.
Okay.
And thank everybody else for listening to Brenner-Fiedler's This Automation Life. If you have questions about what you just heard, or you have a topic you'd like to hear discussed, please email us at tech@brfa.com. That's tech, TECH, @brfa.com. Making sure I spell it because we're hoping to get some more emails. Be sure to continue tuning in each week and upcoming episodes. We're going to discuss some measurement topics. I think we're looking at terminal blocks, communication protocols. We got some good stuff lined up. So
I'm excited.
tune in, sign up for the podcast, listen to it, ignore your children, and listen to us, whatever it takes, okay? Thanks. Bye.